Hello and welcome to my Physics 2212 Lab 4 Magnetic Field of a Bar Magnet. The purpose of this lab is to gain a deeper understanding of magnetism by measuring the on-axis and off-axis magnetic field produced by a bar magnet. The physics principles used are the magnetic field parallel and perpendicular to the axis, with the formulas given. A brief preview of our experiment is that the parallel magnetic field is proportional to 1 over r to the 2.9 and that the magnetic dipole moment of the magnet is 11.42 joules per Tesla. The assumptions made are that the phone is perfectly aligned with north, that the magnetometer on the phone is on top of the ruler, and that there is no interference from other electronic devices. The system is the phone and the bar magnet, and the surroundings are everything else, including Earth. For our on-axis experiment, we moved our phone across the ruler, recording the magnetic field in the x direction. The graph shows our results. To calculate the magnitude of the magnetic dipole moment, we take the natural log of the on-axis magnetic field formula. Then we set this equal to the equation from the graph in the previous slide. Finally, we solve for mu and get a value of approximately 11.42 joules per Tesla. The procedure for the off-axis experiment was as follows. First, move the phone across the ruler until the magnetic field is 100 microtesla. Record this position down and then move the phone to the given position. Once in the new position, record the magnetic field due to the magnet, which is given by the difference between the net magnetic field and the Earth's magnetic field. The table shows the results. The average over the 3 trials was d-perp equals 25.5 centimeters and the magnetic field had a magnitude of 47.1 microtesla. This slide explains how I programmed my computational model. First, I set the magnitude of the magnetic dipole moment to 11.42 joules per Tesla. Then I determined the different observation positions, and finally I set d-perp to the value from the previous slide. To calculate the magnetic field at a given position, I simply use the formula shown above the image. These are the results of my computational model. The magnitude of the magnetic field at the off-axis position was approximately 38.5 microtesla. Both the experiment and the computational model predicted similar values for the magnetic field off-axis. However, they were not the same number. The direction of the magnetic field was the same in the experiment and in the computational model. Some sources of error include the fact that the Earth's magnetic field likely had some effect on the experiment's measurements. The magnetometer was not ideal, and that there was some human error involved in the measurements. The first additional question is what if the phone was not oriented to compensate for Earth's magnetic field? In this case, the field would affect the measurements in all 3 axes. However, we could measure this field and subtract it from all our measurements to get the same results. The second question is what if you stuck 2 magnets together and rerun the experiment? The 2 magnets would produce a new magnet that is twice as strong because their magnetic dipole moments would align, making a new dipole moment that is twice as strong. Therefore, every measurement would be scaled by a factor of 2.